Alright, seems like we're on. Hello guys, this is Shuo Liu. Right, today we are going to make a demo of how I get through the first lab of Ee542. Alright, let's do it. So first of all, let's go to the tutorial page of this lab. As you can see here, this is the environment that we should know before we actually doing the experiment. So this is user 1, this is the control server. It's kind of like the master server of all the other computing nodes of the resources that we need. Alright, so as you can see, after you log in using your account and your password, you'll be entering this page. Right, now let's go to the tutorial. So first thing first, we have to design the topologies, which is pretty important in the experiment when you want to build a network. Alright, so how we the configurations, a huge part of the configurations are done using this NIS file. And let's go to the slides. Right, this is experiment description, and this is basically a graph that shows us how the example tutorial want us to do. This is a network, you can see from here. Right, this one is the overall goal of the first lab. Right, we are going to create a network using the Data Labs machines, those resources, and we have to just leave the resources to others when we finish our part of the experiment. Right, first thing first, step 1, design the topology. So right, we use the NIS file right here. And actually, what is an NF file? It's a network simulators right here, and you can consider it as kind of like a bash file, and you have like multiple lines of commands in it, and you can edit it using some text editor. For example, I am using the text editor on the building one in Mac. Alright, so let's go back to the slides. Right here, this is a graph we saw just like several seconds ago. Alright, so this is the beginning of this NS file. As you can see right here, we are setting up a new network simulators right here, and this is kind of like an imported library, and we are using this TCL file, and we will be using some command that we got from this file. Alright, so next thing that we are actually create 4 nodes, A, B, C, D, and we are building some links right here and building a line, of course. And next thing, we're going to decide what kind of like operating system that we want to be operate on those nodes. Makes sense, right? Yeah. And we are enabling routing, and alright, finished. We run our simulators. So how do you say? Let's just download the. I've already downloaded the NIS file from the web page. Let's open it. Right, like I said, you have to open it with some text editor right here. Cool. As you can see right here, this is what we've been given from the tutorial. So there's like a breakdown in my slides for different part of the NIS file. The first part, declare a new network simulator. The second part, create all those nodes. The third part, just the third and the fourth part, just create the link and the line to connect all those nodes, and also specify the parameters like bandwidth, latency, blah blah blah. And alright, so next thing we are going to specify the operating system. Note that this part may need some modifications. I will do it later. And right, so enable routing and start the simulator. Cool. So after we know how the configurations like the NIS file works, the next thing we are going to create a new experiment right here. Alright, let's do it. So the project is fixed because right, we're on this. The root is like the Ee542. So the group is fixed as well. So right, let's create one. Shuo. Alright, so this is like the text for demo number 1. Alright, as I said, like I encounter some error when I use the default NS file. So this is where I did some troubleshooting from the log. You can see that the log says the error message is like this sort of hardware cannot run this sort of operating system. It's pretty natural when your hardware cannot run this one kind of operating system, you will switch to another one, right? Switch to another operating system. So in our modifications, so we use Ubuntu instead of the default operating systems. Alright, so let's go to the main page. Test for demo number 1, and right. So I'm pretty sure that I have a NS file that have already been moderated right here. Cool. As you can see that everything is the same besides we change the operating system right here. Alright. Sounds reasonable? Yeah. I'm pretty sure this is the natural way that everybody will do. Just change another operating system and pray for good luck. Alright, so we update the NS file, and also I click the swap in immediately so that I don't need to manually swap in after everything is good. Right, so we submit the code right here. As you can see there, there's like there's a parser to pass all our NS file right here, and you can see that this is like a command line like user interfaces, which is pretty good. You can see how the system processing your experiment, and also you can see the bugs if you have some. And right, this is like a good way for us to know how the Data Lab try to allocate all those resources for us according to our NS file and other configurations. Right. So loading the operating systems using that Ubuntu. So as you can see here, this starting experiment process will take several minutes. So right, just be patient. You will be receiving a email notification says like your experiment has been successfully started. Alright, so as you can see here is that, and I do receive this email says like your experiment has been started. Alright, so next part, let's go back to the slides a little bit real quick. Right, let's go to since we have already started our experiment, so it's pretty natural. Let's go check the information of this experiment. As you can see that we have a set bar here, so we can modify the settings, modify the experiment, and also modify the traffic shaping, like the latency, bandwidth stuff. Right here, as you can see that we have our node ABCD right here. Visualizations, as you can see. Right, this is what we want, exactly what we want. Alright, NS file, this is the one that we've been using. This is like the detail of the experiment. So be careful with this part, we'll be needing those addresses later. So yeah, So pretty good. So far so good. Let's go to the tutorial real quick. Right, as you can see that the step 3 is to access all those nodes. We are going to access remotely to those nodes, the computers. So in order to get to all those nodes, so first of all, we are going to SSH to our master node, master server, right? So you have to input your password here, right? We're good. We're in, right? So if you do an ls, you will see all the files that under your home directory, your specific user. For me, it's USC 542 BU. I'm not sure why there's BU, but I guess there are just some combination of characters. Alright, so let's go back to the slides. Right, this is where we SSH to the master server right here. So we're trying to access to all other nodes. So we just take node A, for example, right here. Alright, so let's go back to the information, the detail page of the experiment, and copy the address of the node A, and we SSH it in the master server, as you can see right here. Cool. So we are in right here. So we are actually, the user is still me, BU, and we are at the node A right here. Sounds good? Alright, let's go back to the slides. So now we are heading, to step 4, which is view result and modify the experiment. So yeah, you can see the first paragraph is basically talking about that we can modify and viewing all the results of our experiment by using some web user interface, which is exactly the one that I showed you guys a little bit earlier, right here. As you can see that information slides, the setting part, so the visualization part, set bar, all the options that we can do it, like swipe out, terminate, modify experiment, modify settings, modify traffic shipping. Cool. Alright, this part is when you click into it. So you can change all the configurations, parameters, bandwidth, latency. Cool. So right, besides using the web GUI, so we have another way to do it. So we can use this command line. So right, this is like the format. You use those informations and let's go to it. Right, it's like you use project and experiment ID to operate to find which experiment that you want to make modifications on. Right, cool. Alright, so we use this as an example right here. We're trying to modify the link 0 and modify the delay to 1. Previously it's 0 in our experiment, but we want to make it to 1. Let's copy paste the command line. Alright, so the thing is, in order to modify the experiment, you cannot do it on a single node like I did. So you have to go to the master server, the control server. So right, let's in the connections. So now we are back to the master server, the user control server. You can see right here. So we paste. So we copy and paste the command line one more time. Do it right here. Oh yeah, my bad. we still have that link 0? Let's check it real quick. We do have it. We have it, right? So the name is still sh. Ah, I got it. It's because I just copied it from the PowerPoint, so there are some characters. Alright, so fix it. The thing is, there are some space between here, which cause the error, which doesn't fit to the format. Alright, seems like pretty strict. Alright, so as you can see here, we just change the delay of link 0 to 1. Let's go back to the slides. Alright, we are going to take a look of the step 6, save your work and swipe out. So right, in order to save and secure your file on Deter Lab, you have to basically right, you have to take care of like the Deter Lab will wipe out the files that not in the permanent folder. So yeah, make sure that you save your work in your home directory before swiping out your experiment. For me, you can see in here in the command line. Right, let's clear it. So do ls, you can see those files. Every time I swap out, swap in, those files remain there because that's those are the permanent folder of mine. So everything there stay there. But if you store your file in some not permanent folder or directory, every time you swipe out, swipe in, those files will disappear. Right, so there's like another place you can store is the project folder, and inside it is your project. For me, for us, is Ee542. But the thing is, if you store your code here, so everybody will see it. So yeah, might not be a good choice, I guess. So next thing is to swipe out and terminate. So the differences between those are, if you swipe out, you can swipe in again, so the configurations will stay there. If you terminate, it will delete all your experimental and all the configurations. Alright, let's go back to slides. As you can see here, terminate will erase all the experiment, and swipe out doesn't. And right, you can schedule a swipe out and terminate. So you have to use some like command in the NS file, which is pretty good if you want to make the best of use of the resources. Right. So this is the one that we talked about scheduling. Next thing is how can we installing RPMs, Red Hat Package Manager automatically instead of we just manually copy and SCP the file into it and just install it. Automatically installing might be a better choice, right? So the thing is, we have to modify our NICE file right here. Let's go back to the slides. Right, this is what I'm doing. So in order to right, it's pretty natural. You don't want to upload your own RPMs. I mean, it's okay, but it's better to check out what kind of RPM have already been put there before you actually want to add something new, right? So let's do some CDs and let's go back. Let's go up to project. Alright, so like that. CD RPMs, I got you. As you can see that this is all the packages, the RPMs that have already been put there. So let's take this for example. So let's go to our experiment and click modify experiment right here. Right, this is the command tb set node RPMs. This is like the first parameter, which is on which node you want to store it, and this is where those files comes from. Let's copy and paste this one right here. I want to install this on the first node, node A. So the project name, remember to change it. So we are actually talking about node. Copy and paste this one. Alright, sounds good. So let's click modify. This will take a few minutes, so just be patient. You will receive an email as well. So yeah, as you can see that our modification has been successfully. Alright, so there is like a bug right here. Let me check. Oh yeah, I got it. So there's like another part of troubleshooting I didn't really mention. You need just mention a lot in the slides. As you can see there, the node A here, we use CentOS, not Ubuntu, because RPM is not like defaultly compact with Ubuntu, so you have to use another stuff to make that you can use RPMs on Ubuntu. So, but you can use RPMs directly on the CentOS. So, right. So we have to, of course, we have to change the operating system of Node A to CentOS. Alright, let's go check. Right, this is where we can find all the available options for us to let's check which one I've been using. Okay, I've been using this one before. So right, let's change the operating system on Node A. Alright, let's do that again. So right, yes, you can see that we should change the Ubuntu to CentOS because RPM are built-in compact with CentOS, not Ubuntu. If we are just directly trying to implement RPMs on Ubuntu, we will face an error. So as you can see here, I changed the operating system of Node A from Ubuntu to CentOS, and right, this is where we want to install this one, which to the Node A. Alright, let's do it. As you can see here, the swap is successfully finished. So so let's just swap our experiment in again. That will take several minutes. So let's go back to the slides. Right. Thing is, you have to be careful that some functionality only works when you are trying to deploy a certain kinds of operating system on a node. So if you have some error when deploying the NS file, and you can just check the log, trying to figuring out which part is wrong and how to fix it. Could be pretty straightforward, I guess. Alright, so we will be waiting this a little bit more time. Alright guys, so you can see that the swapping process was finished right here. So let's go to the information of my experiment, and go to the, so as you can see right here, finished this line. So now we can assume that we should check in the node A. Alright, so let's go grab node A's address one more time. Cool. Alright, SSH back to node A. Alright, let's right, so we use this command to see if we do have this way. Okay, as you can see here, we do already have this in store. So that means our configuration works. Cool. So, right, next section we're going to try to install the tar file automatically. So, right, as you can see here, I've already read the codes. So we are trying to install this MySQL to node A. Alright, so we also changed the operating system of node A back to the Ubuntu. Alright, so we just copy the whole thing, and we just modify experiment, and alright, so let's do it. So now after this we'll be waiting for several minutes again. So let's wait. Cool. As you can see here, we have already successfully swapped in our experiment. So next thing is we are going to node A in the terminal, and weird. Alright, got it. Right, as you can see right here. Right, we have a MySQL. This is the one that we installed right here. Cool. So we're heading to next part of our experiment. So next part of it is starting our applications automatically. So we want to start a application on a certain node automatically. So before we actually do it, it's pretty natural that we want to know, is there any application have already been on those nodes that we can just use it directly without just writing some applications and upload it there? Yeah, why not? We should definitely check it. So we are going to, cool. So let's see what we got. So this is everything that in the project, our project folder, and the one that I've been using is this shell file .sh hello shell, and in order to see what is the result of it, we can just we can just run this shell on the server, where as you can see that. Cool. Seems like someone has already been modified this. So, alright, so we just memorize this to see if we can. I'm not sure if you guys want to change a little bit. Alright, so cool. As you can see that, hello. Now I'm just, alright. Come on. Jeez. Alright, so I've already changed the shell file. Someone make it like someone changed the change it to read only, but I change it back because this is a file that on a shared folder. So I'm not sure if it's okay to make it read only because everybody can use this. So right, this is, as you can see right here, this is like the final result of the changes. Cool. So right, let's go back to the slides. So we add a line like this, so we automatically run this hello shell file, and we write the log to this folder. Alright, let's we just try it real quick. I want to copy and paste some of the codes so that I don't want to write a lot. Alright, so we are operating on node Ee542 and hello.sh. Sure. Alright, let's do it. So as you can see, we have already successfully swept in, and wait, let me check if I think we actually installed it on node A, right? It's node A, cool. And let's go to node A, and I think where is the log? PMP. Alright, so we have the log, but we want to read it. And, right, as you can see that this is the log we should have. Alright, so cool. Next part, we can notify and start program when all other nodes have started. So yeah, let's do it. So since we have already seen this, someone else modified this, so we can just directly use it. As you can see here, so we want to use Node B as a synchronized server, and this is like how the logic goes. So next part is to set up an IP routing between nodes And previously we are using static routing protocol, but let's go back to the slides. For now, we want to do something manually, so this is how our manual codes do it. So let's modify the NS file. So you can see we just use like three nodes out here, and right. As you can see here, this is our modified code NS file. It's up and running. Seems like some. I don't know what happened here. Let's check it. Okay. Alright. Just give me 1 sec. Yeah, so we'll make a few changes and I'll show you guys the nice file later. So let's wait. As you can see, it's successed here. So let's go to experiment visualizations, and you can see the links between all those nodes, which is manually built by us. So right, so this is like the wrap of this demo. Thanks for watching.